Hello. Today we're gonna just go through how the Crazy Fly simulation comparison with reality demo works and how to do it. So the first thing is, in order to actually get it to run on the drone, you have to have the lighthouse set up. In order to configure that properly, we should have another video on the Microcart channel. And there's also a lot of widely available documentation on it. And there's also an article on the Microcart wiki for how to get the lighthouse to work correctly. But there is this script in the Microcart repo under Crazy Fly demos. And it's called basic hover demo matlab.py. So basically what this does is it, as you should have seen from the beginning of the video, flies the Crazy Fly up and then flies in a square. While that's happening, it's logging the position and the pitch, roll, and yaw. And then when it's done, it saves that to a file. It saves it to a .mat file. And then the way that the simulation part works is there's a nonlinear simulation that Jones gave us at the beginning of the year that we've been playing with. And basically we gave that a series of set points. And we are just plugging that into a drone visualizer. And then we have the same thing plugged into the logged data. So let's step through the Python script here for a little bit. There is this wait for position estimator function. What this is supposed to do is basically the Kalman filter for the drone may be initialized wrong. So what this does is it resets it and then waits until it converges on the actual position that the drone should be in. So like the variance of it is low enough. But what this ends up doing is kind of just mixing up the logging, and you end up getting this weird spike at the beginning of the logging. And so most of the time it's best for this demo to just not have this. And so at the beginning of the script, we actually have that line commented out. This reset estimator is what runs that. And in order to make sure that the Kalman filter actually does know where the drone is, what you have to do is in VirtualBox, you should have your CF client. You run that just using CF client in terminal. And you'll want to upgrade that CF client to the latest possible, because otherwise you won't be getting the best lighthouse information, and that's just a pip upgrade. And you can tell that it's converged on position if you connect to it. And I may have to connect to my USB stick here again. I think I do. There we are. I may have crashed my CF client here. Let's restart it. Wow. So we'll start that guy back up. We will make sure that the USB for the Crazy Radio is connected, and we'll connect to our Crazy Fly. Okay, so now you're connected to the Crazy Fly. It says its position. I have it at 00 right now. And that is what prints out here. You can also go to the Lighthouse Positioning tab. And this little dot in the center of the screen is where it thinks the drone is. And also we can see that it's seeing the lighthouses because they're all green. So that's good to go. And then this is basically all you need CF client for. So if you just click disconnect and then unconnect your USB stick, now you can go back to PyCharm. And basically all you have to do is just click run. So I run all my Python stuff through PyCharm because it just makes things very easy. So if you just click run, you can't see it, but the drone's about to move. Oh man, there it goes. This is so exciting. Yeah, that's about it. So then what this ends up doing, as I said, is it saves a MATLAB file to this sim nonlinear quad example folder, this measured flight path.mat. And now we can hop into the MATLAB side of this demo, and I will explain that to the best of my ability. So there's quite a bit of stuff in this folder. The thing you're interested in for this demo specifically is the logs versus simulation Simulink block, and then you're also interested in quadparams.m. So what quadparams does is it basically initializes the simulation to be correct, and the reason that that's necessary is that this actually uses the MATLAB workspace for the simulation, because that way we can write the whole simulation in MATLAB function blocks, because that's something that Jones wanted. And we can look at what it is here. So this is the actual Simulink logs versus simulation function block. And this is everything it takes to do the drone simulation. This is a series of set points that are changing with time. So this first one is do nothing until at 2 seconds, set the Z target to be 0.66. And then the next set point change is add 0.5 to the, I think that's X, and then 0.6 to the Y. And yeah, that just is what takes it around in that square. And then this is just the simulation visualization that's from a previous version of the Simulink simulator from a previous microcart team. And yeah, if you click into this VRSync, that's what pulls up the 3D visualizer for the simulation. And then this is just basically the exact same thing, but with the .mat file is this .from file. And then it just goes into the logged visualization. And that's about it. So as soon as that PyCharm is done running, what you can do is just open up Simulink and just hit run. And so long as all your packages and libraries necessary for this Simulink block are installed in MATLAB, it should work. And this is what it ends up looking like. And so you might be thinking, it seems like our controller is not doing what the real controller is doing. And that's kind of because this is really just to trick incoming students, because this controller is actually an LQR controller, and we're not giving it the same speed set points that the drone in real life had. So this is really just meant to look convincing, less so than be the full comparison between simulation and reality. But regardless, this is how it works. So hopefully this has been helpful, and it has helped reproduce the demo if that's what you're trying to do. If you need any help, future microcart team, feel free to reach out to me. Dr. Jones should have my contact information, hopefully. Or yeah, good luck.